afternoon, guys. So today what we're going to be looking at is how do I use my logarithm rules to actually help me solve an exponential equation. So for example, let's say I look at example 1. You have 2 to the 3x minus 7 equals 32. Now there's more than one way to solve this equation. I'm going to show you a method that works every time today. Okay? So the first thing that I want you to notice here, my first step here is to take the log of both sides of this equation. So that same rule holds true. I can do anything to an equation really that I want to, as long as I do the same thing to both sides. Why did I take the log of both sides? Well, here's the problem right now if I try to solve this equation. My x is stuck up in the exponent, and I don't know how to solve something like that. Well, if I take the log of both sides, there is a rule that says with logarithms, having an exponent is the same thing as flipping that exponent to the front and distributing it to the logarithm. So what I can now do is I can say I have 3x minus 7, I can swing it down front, times log of 2 equals log of 32. Okay? So what I've just done is I've taken that x out of the exponent. Now it's a lot easier to deal with. So how do I now get x by itself? And there's a couple steps here. Well, step 1 is I have this log base 2 now that is being multiplied by 3x minus 7. Well, how do I get something that is being multiplied to the other side of the equation? Well, I divide it. So your first step is to say 3x minus 7 equals, and then you're going to have a fraction. You're going to have log of 32 divided by log of 2. Okay? What's my next step? Because at this point, x is still not by itself. Well, I have a 7 that needs to be added. Okay? So I say, well, now 3x is equal to log, I need a fraction there. Log of 32 over log of 2 plus 7. Just to simplify things, I'm going to type that in Desmos so we can get a decimal for that. So log of 32 over log of 2 plus 7 as a decimal is just 12. So what I actually have here is that 3x equals 12. That's pretty easy to solve. How do I solve that? Well, I divide 3 to the other side, and I find out now that x is 4. And I'm done. Okay? Let's take a look at example 2. Same kind of scenario here. I have an x that's stuck up in the exponent, and I really don't know what to do about that. Okay? Previously, you really haven't learned a method of how to solve that. But what's my trick when I get an x stuck in the exponent? Well, I can take the log of both sides of that equation because one of my logarithm rules says that an exponent is the same thing as taking that exponent down and multiplying it times the logarithm. So I swing that exponent up front so that I have x times log 3 equals log 20. Well, all I have to do now to get x by itself is to divide log 3 to the other side. So I just have x equals, and then I have a fraction here, log of 20 over log of 3. And nobody knows that off the top of their head, so we go over to Desmos, log of 20 over log of 3. And normally I believe Desmos will have you round to about 3 decimal places. So that'll be about 2.727. Okay? Alright, so a couple more examples and we will be done with this video. Let's say you look at something like example 3. There are a couple things that are different about this one. The first thing you should notice here, there's a step that's doesn't really have anything to do with logarithms here. It's just a basic equation step. There's a 100 being multiplied by e to the 0.08t. So I can go ahead and actually combine that 100 and that 2500 just to simplify things down. So if that 100 is being multiplied right now, the way that I get it to the other side is to divide it. So 2500 divided by 100 gives me 25. So all that I'm actually dealing with here is e to the 0.08t equals 25. Well, how do I solve that? Well, I know I'm going to have to take the log of both sides because my variable here, my t, is stuck in the exponent. And that's the only way I can pull it down. here's what's different. If you ever see an e in an equation, e goes with natural log, not just regular log. So what you're going to have here is natural log of e to the 0.08t equals natural log of 25. That is the only thing that's different about this example. Okay? Works exactly the same way. Now that I've taken a logarithm, I can pull that 0.08t down to the front. So 0.08t natural log e equals natural log 25. And here's what's nice about this equation. Natural log e, if you type that in your calculator, it's just 1. It cancels itself out. So all you have here is 0.08t equals the natural log of 25. How do I solve that? How do I get t by itself? Well, I take natural log of 25 divided by 0.08, and I get that t is 40.236. And then I'm done. Right? All right, couple more examples here. Example 4. So again, first step, no surprise here. Take the log of both sides. Okay, there's nothing else I can really do here. There's nothing I can simplify or combine. So then what am I able to do now because I took the log? I can take my exponents and swing them down to the front of the logs. Okay? So at this point, I've got to try to get x by itself, and this is probably the trickiest problem on here, so make sure if you have questions about this one that you ask me. The first thing I'm going to do when I end up with an x on both sides of my equation is I'm going to go ahead and take this x plus 3 times log 4 and distribute it so that it looks like this. I have x log 4. Oh, didn't want to capitalize that. Plus 3 log 4 equals negative x log 3. Well, now what can I do to kind of start to get my like terms together? Well, I can take anything with an x and put it on one side, and I can take anything without an x and put it on the other side. So what I'm going to do here is I'm going to leave the x log 4 right where it is, but I'm going to reverse this negative x log 3 so that it's on the same side, and then take the 3 log 4 and move it by itself because it doesn't have any like terms to be paired with. So that'll be a negative 3 log 4 since we shifted it to the other side. Okay, once we've gotten all our x's on the same side, here's what I can do. I can actually, it is factoring. We don't always think about it that way, but that's what you're doing. You can pull out what these two logs have in common. You can pull out the x that they both have. So if I pull out the x, what's left? Log 4 plus log 3 equals negative 3 log of 4. And at this point, I'm almost done. How do I get x by itself? Well, the way I have this written, x is being multiplied by this whole thing in parentheses here. So how do I get that to the other side of the equation? Well, and I'm going to have a really ugly fraction here. I take everything that's in parentheses and I divide it to the other side of the equation. So what I'm actually typing in Desmos looks like this. Negative 3 log 4 divided by log of 4 plus log of 3. And I type that whole thing in here. So negative 3 log 4 divided by log 4 plus log 3. And when I do that, my answer here is negative 1.674. And then you're done. All right, very last example for this video. So let's say you see something like this. Solve e to the x plus e to the negative x minus 6 equals 0. Here's the thing. There are ways to solve this by hand. They are very ugly, and I don't feel comfortable teaching them to you when I'm not in a classroom where I can answer questions about it. Here's the easiest way to solve something really ugly like this. Always remember, solving equations are the same thing as finding an intersection. So what you're actually looking for here is where does this big old ugly expression intersect 0? Well, I can find that using Desmos. So what I'll do here is I'll type in e to the x plus e to the negative x minus 6. And then I'm going to go look at the graph over here on Desmos and find where it intersects 0, or the x-axis. Well, it intersects once here at negative 1.763, and it intersects again at positive 1.763. There's my two answers. That's all I need. So x equals negative 1.763, comma, 1.763. And then you're done. Okay, if you would like to see the way to do that by hand, my math lab does show that to you, and you're welcome to do it that way. But here is a quick way that you can answer questions like those. So that's it for section 5.5a. Please let me know if you have any questions at all.